elements. One is the control systems and computers and logic systems, software and acquisition, sensors and actuators, and physical system modeling. These are the 5 the basic key elements of the mechatronic system. The feedback control encompasses aspects of all 5 key elements of mechatronics, but is associated primarily with the element of signals and systems as illustrated in the figure. I will show in the next slide. Now, these are the basic 5 key elements of mechatronics. The first one is the control system. So, the control system function is it will control the entire system parameters. Okay. Entire the system parameters the will control to the desired inputs and desired outputs. Okay. And this control system will connect to the computers and logic systems. So, what is the main function of every one of us knows that the main use of computers and logic system, different logic systems are built up and that program softwares are included. Okay. Through these computer systems we are interact with this control system and the whatever the softwares are inbuilt, different functionalities require the different softwares and acquisitions. So, from the different softwares and acquisitions it will send to the sensors and actuators. Okay. Sensors is a device which get the feedback from the given element, and actuators are a element which actuate that mechanical the actions, that movements. Okay. So, sensors will give the signals, according to the signals the actuators will work, and these actuators will work and that will goes to the physical system modeling. The physical system modeling will. So, now you can see this entire this process is call it as a mechatronics. The mechatronics is a control systems. From the control systems it will control these signals and flows from the computers and logic systems, and from this computers logic systems will interact with the software, the acquisition of the different results, and this will give the signals to the different sensors. It will take the feedback from the sensors and it will give the signal to the actuators, and the actuators it will work the real the physical models that will be activating, and that how it will be acting, that information also it will take this control system. So, see each element is connected in both the ways, each element is connected in both the ways. Information will flow from the control system to the computers and logic systems, and computers logic system to the control system. Similarly, for this computers and logic system to the software and acquisition, and software acquisition it will go back to the computers and logic systems. So, they see that arrow marks is indicates both sides the information flow in either direction information will there, and this entire setup, the entire setup is called it as a mechatronic system. The entire setup is called it as a mechatronics system. So, the control system design process. So, now we have seen what are the different key elements of the mechatronic system. So, now we want to design the control system. For designing the control system, what are the different the steps, the procedures that will be explained through these steps. The step in the process is the adjustment of the parameters of the system in order to achieve the desired the performance. If we can achieve the desired performance by adjusting the parameters, we will finalize the design and proceed to the documents and results. If not, we will need to establish, improve. So, this entire this stepwise procedure will explain through this the diagram. Now, you see this, with the help of this you can understand how the control system design process will be there. So, the first step is establish control goals. Okay. So, what are the parameters we are going to control? So, that we have to first establish these goals. Once we are establishing these goals, then identify the variables to be controlled. Once goals are established, then what are the different variables are available, which variable we are going to control to achieve our desired goal. Okay. So, the second step is identify the variables to be controlled, and the third one is write the specifications for the variables. Each variable there is a set of the specifications are there. So, for example, if we take a CNC lathe machine and CNC lathe machine will work, what are the specifications? The specification generally can speed, feed, depth of cut. Okay. So, for different operations and we require the different speeds, different feed and different depth of cut. Okay. These are the specifications. So, you can write the specifications for the variables, like you take different variables, you have to write down the what are the specifications of those variables and establish the system configuration and identify the actuator. Okay. We can establish the configuration and identify this what are the suitable actuators will work according to our desired specifications and obtain a model of the process, the actuator and the sensor. So, the actuator and sensors are very important in take any mechatronic system, there is some sensors and some actuators will be there. Okay. So, now can obtain the model of the process, the actuator and the sensor. Describe a controller and select key parameters to be adjusted. So, you can control what type of controller is required, you can describe and select the key parameters to be adjusted and optimize the parameters and analyze the performance. You can optimize the set of parameters and you can analyze the performance, and if you see that if the performance does not meet the specifications, if the performance does not meet the specification, then iteration will start, it will go back to the configuration and actuator. It will, so if here you can analyze the performance, the performance is not meeting the desired specifications, again it will go back to the as the fourth step, establish the system configuration and identify the actuators according to the set of the specifications already you are set, and based on the specifications whatever this identified actuators are not giving the desired results, then you can change the another actuators. So, this iteration process will continue till it will reach the performance meet the specifications, then you can finalize the design, then it is finalize the design. So, this is the sequential stepwise procedure to design the control system. We take any, it is a general for a particular control system there is some variations may be there, but in general if you take any control system, these are the sequential steps we are following to design the control system. So, now coming to the human, you see our human being having the, there is a several the number of sensors, number of actuators are there. Okay. Now, see the few examples are quoted. So, the pancreas, it regulates blood glucose level. Okay. So, it will control the glucose level of the blood. Okay. The pancreas will regulate the glucose level of the blood, and adrenaline automatically generated to increase the heart rate and oxygen in time of the flight. Okay. So, the oxygen generation and that will be controlled this early. So, like if you see that our eye, so our eye is used to follow the moving object, you can able to see the different objects and their positions you can see with the help of this eye. And hand, this hand is having this one type of actuators, this movement, okay, nervous system, this actuators, how this, suppose I want to move this hand, how it is moving, the signal is coming from the brain through nervous to this, so it is acting, this is acting as an actuator, there is a link, so this is one link and another link, and here is a revolving joint. Okay. So, like the different so hand is a pick up an object and place it at a predetermined location. Okay. So, the temperature, we are maintaining the temperature of the body. So, the temperature is also very important. So, regulate the temperature generally for 36 to 37 degrees, 35 to 37 degrees, we are want to maintain the body temperature. Okay. Like similarly, for take any element, any object, that object also will work in a set a specified temperature. If some components are working at room temperature, it gives the desired results, and it may not be getting the same results if it will work at a exposure to the high temperatures like a 600 degrees centigrade or 700 degrees centigrade. So, that means you have the set of the requirements, based on that the performance will be there. So, that is called as a human system. So, our human system is the best example of the mechatronic system. You see our top to bottom there is thousands of sensors are there. Okay. Suppose if you see this in your hand, if you just press it, then you feel pain. How the pain is you feel. Okay. So, that is from the skin, how it will be transferred to your mind, and it will see that what is happening here. Okay. So, like that every action in our human being is taking the best example of this mechatronic system. Control system components. What are the different components for the control system? That system, plant or process to be controlled, and actuators that converts the control signal to the power signal, and sensors provides measurement of the system output, and a reference input that represents the desired output. So, this control system, the basic components, and the general control system we can explain through this flow diagram. Now, if we see that the set point or reference input, the reference input we are giving, and this is call it as a comparator. The comparator, the function is to compare the input signal to the output signal. So, now here this input signal, that is our desired input signal we are giving. Okay. And once we giving the input signal, it will send to the controller, and this controller will according to the signal it will send the signal to the actuators, and these actuators will work as per the given signals. Okay. And here the some depends upon the system, some manually that manipulated variables, some variables you can manipulate it to get the desired signals, and it will goes. This is the final process.